In this video for section 2.7, we're going to talk about inverse functions and graphs. Throughout this activity, we are also going to find the inverse of a function and determine whether or not two functions are inverses using algebra. But we're going to start with the graphs. So here we have a graph, and our first question is to use the graph to find f of 4. So we have function notation here. But when we have function notation, the number that's in the parentheses is the x-coordinate, and the f of that number is the y-coordinate. So another way of phrasing this question is to find the y-coordinate when x is 4. So looking at the graph, find 4 on the x-axis. Remember, x is the horizontal axis, y is the vertical axis. So 4 on the x-axis, looking at the graph, it looks like the value of y there is 2. So f of 4 equals 2. Now we have this notation introduced. F inverse looks like f to the power of -1. What the inverse function does is it switches the x and y coordinates. So since 4, 2 is a point on the graph of f, so we have this point that we just found, 4, 2. The point on the graph of the inverse of the function is going to be 2, 4. My x and y coordinates flip-flop. So f inverse of 2 is going to equal 4. Or another way of saying this is that for the inverse function, our original input is going to become the output on the inverse. Our original output is going to become the input of the inverse. So again, x and y are switching. So looking at question 3, find f of 1/2. What does your answer mean about f inverse? So let's look at my graph, f of 1/2. Notice that this graph, I have marks every 2 spaces. So 1 on the x-axis is going to be here, 1/2 is going to be here, and the value of the graph there is -1. So f of 1/2 equals -1. What does your answer mean about f inverse? It means that the point -1, 1/2 is on f inverse. If you haven't seen this already, a way that I can type these superscripts or exponents is using this x squared button that you might have somewhere on your toolbar. So if the point 1/2, -1 is on my original graph, the point -1, 1/2 is on the graph of the inverse. Number 4 says to fill in the blank. F of blank equals 0. What does your answer mean about f inverse? So on my original graph, I want to see where the y coordinate is 0. And I can see that that's at this point right here, 1, 0. So the point 1, 0 is on my graph. What does your answer mean about f inverse? Well, again, we are just switching the x and y coordinates. So the point 0, 1 is on f inverse. Question 5 says to find f inverse of 3. So again, we're looking here at 3 being the y-coordinate on the original graph. So if 3 is the x-coordinate on the inverse, 3 is the y-coordinate on the original graph. So when I go to 3 on the y-axis and go across to the graph, I can see that the x-coordinate there is 8. So f inverse of 3 equals 8 because 8, 3 is on the original graph. And then finally, question 7 has us click on this Desmos calculator link to view the graph of f and f inverse. What do you notice about the graphs? So when you click on the link, it should open up this Desmos graphing calculator. I see the red graph here is my same original graph that I have in the activity, and the blue graph is the graph of f inverse. And what it should look like to you in when looking at the graphs is you should see some symmetry. It should look like they are reflections of each other. And they are in fact reflections over the line y equals x. So I'm going to add that line to my graph here so that you can see it. I'll change the color of it just because. So you can see that if I look at this line as kind of a line of symmetry, that the two graphs are mirror images of each other over that line of symmetry. So there might be other things that you notice as well, but the main thing that you want to notice is that they are reflections of each other. They are symmetric over the line y equals x.